Hi everyone. Particle P is initially at the origin, O. It moves with the velocity function via t equals t squared minus 4t plus 3. We're going to write a formula for the displacement function and find the total distance traveled in the first 3 seconds of motion and the displacement of the particle at the end of 3 seconds. So to get started, we're going to first find a formula. And we basically need the displacement function. That means we're given the velocity, and to get the displacement, we have to integrate. So we're going to integrate v of t dt. And so that's really going to be the integral of t squared minus 4t plus 3. So when you integrate dt, when you integrate this, you're going to write t cubed, you add 1, divide by 3, minus 4t, we need to add 1, so that's 2, divide by 2, plus 3t, plus c. So our s of t, as you simplify, is just going to be t cubed divided by 3, plus 2t squared, plus 3t, plus c. Now to find the final formula, we know that we've given that the particle initially is at the origin. So we know that S of 0 at time 0 is 0. So when you plug in 0 into all these t's, you're going to get, let's plug in 0. You get 0 divided by 3 plus 0 plus 0 plus c. Well, this equals 0, so 0 equals c. So basically, your final formula is just going to be t cubed divided by 3 plus 2t squared plus 3t. Now, to find the total distance, what we're going to do is first, since we can't use a calculator, we know that Vt equals t squared minus Vt plus 3. So we want to set this to 0 and see what our values are, so we can do a sign diagram. So you factor this, you're going to get t minus 1 and t minus 3. So that means at our function v of t equals 0, we have 1t is at 1 and the second t is at 3. So that's at your time 1 second and 3 seconds. So let's do a little sign diagram. I'm going to do 1 and 3. And we also know that S of t equals t cubed divided by 3 minus 2t squared plus 3t. So when you plug in, let's see, since 0 is on the outside and we need to start at 0, so let's plug in 0 in here, and we're going to, or if you plug in 0 there, you're going to get positive. And since it's a cube here, we know it's going to be positive, negative, positive. And you can plug in values and see what it would be. So for example, if I plug in 2 here, I'm going to get positive, negative. So that's what makes that negative. You can plug, we want to go all the way here to 5, because for B, we're finding the total distance. So anytime you're not using a calculator and you have to find the distance, you have to use the sign diagram. And then we're going to use our interval as for our distance. So our distance is going to be the first interval from 1 over the interval 0 to 1 of v t dt. Now to save some space here, what I'm going to do, we already know what this is. This is this equation here, our displacement formula. So we're going to go ahead and just write that out. But technically it would be like this. You write that, and now since we have a negative, you write minus. And now we're going from 1 to 3. And then you write the function here. And then we're going to go, since we have a positive, we're going from 3 to 5. And that's going to be your function here. Now, when you plug in 1, you're going to get 1/3 minus 2 plus 3. When you plug in 0 and subtract that, you're just going to get 0. So this right here is just going to be, and I'm trying to save space, this answer here is just going to be 4/3 minus 0. All right? And then we already know when we plugged in 1, we got 4/3 again, so that's minus 4/3. And then you have your, if you plug in 1, you get your negative 4/3. When you plug in 3, you're going to get, let's plug in 3 first. If you plug in 3, you're going to get 0, because you're going to get 27 divided by 3 is going to be 9. And then this is going to be minus 18 plus 9. So that's going to be 0. I apologize, but I'm trying to save some space here. So that's going to be 0 when you plug in 3. And then when you plug in 1, we already know what that is. So when you plug in 1, remember you have to subtract, so that's going to be minus 4/3. So 0 minus 4/3. Now again, when you plug in 3, you're going to get 0. So we have to start with 5. When you plug in 5, you're going to get 125 divided by 3 minus 50. Let's see. So that's going to be minus 2 times 25. This should be square. And then plus 3 times 5 is 15. And then again, 3 gives you the 0. So finally, when you simplify all this, equals here 20 over 3. So when you add all this up, you're going to get 4/3. 2 negatives make a positive, so plus 4/3 plus 20/3, and that gives you 28/3. And that's going to be your distance. Okay, and then finally we have to find the displacement. So for the displacement, you can do it one or two ways. Since we want to find the displacement of the particle at the end of 3 seconds, so that's from 0 to 3, we can do our displacement is s of 3 minus s of 0. And again, I'm going to give you my s. My s was s of t was t cubed divided by 3 minus 2t squared plus 3t. Put a plus there. So we already know that when you plug in 3, you get 0. So let's go ahead and do it again. So s of 3. That's going to be 27 divided by 3 minus 2 times 9 plus 3 times 3. So that gives you, this is 9 plus 9 is 18, and this is minus 18. That gives you 0. So what we get is 0 minus 0. Because you plug in the 0 on all these t's, you get 0. So this equals 0. Or you could do the integral, and that would give you from 0 to 3. Of your function. And again, that's just exactly what we did. When you use this function after we already found it, you evaluate it. Sorry, I wrote that down wrong, but you evaluate it from 3 to 0. So that's just what we did. And that's it. Thank you. Have a nice day. Bye-bye.